Okay, again, happy Wednesday. If you just came in, happy Wednesday, happy hump day, middle of the week. Okay, so our new notes, if you go to courses, you go to our course, week 14, you'll see our notes. And again, you do not turn in notes. You do not turn in notes. I know it looks like it's an assignment. It's only because so some of you can use Kami. And you can only use Kami if it looks like an assignment. That's just a weird way this works. And then I put the note solutions there in case you want to just look at the solutions. I had a few people in my other classes, and sometimes in this class they did the homework. I'm like, how did you do the homework? I didn't finish the lesson. They're like, oh, I looked at the note solutions, mister, and I looked at the examples, and from what you explained, the half part that you explained, and then what I saw in the notes, I got it. So some people like the note solutions. Some people like looking ahead. That's fine. And then we got the homework. It says it's due Wednesday, which is today. It's not going to be due Wednesday. I'll probably have everything due like I told you the other day. I'll probably have everything due on Monday. This homework, you're going to have 2 homeworks this week. You're going to have this homework, and then you're going to have the radical equations homework, which is what we're going to start tomorrow. So this rational exponents is a very simple lesson. Okay, so open up the notes. Whatever you do, go print them out. Go open them up with Kami. Go put them in a new tab. Get your notebook. Whatever you do, we're going to start a new notes right now. So it is right there in our week 14 materials. Can you believe it? Week 14, 7 more weeks of school. Okay, and then you'll see this. So I'll give you a minute to do that. I'll give you a minute because some of you need some time to get your notes. Some of you are like, no, I just copy what you put on the screen. That's fine too. But let's give everyone else who actually prints stuff out or needs the time to get their notes situated. Let's give them a minute. All right, time is up. So hopefully you have your notes situated. So let's talk about this. Rational exponents. Now, rational just means a ratio, means a fraction. So we're basically, if you want to also see this, you can also call this fractional exponents, right? We officially call it rational because rational means a ratio. And so what do I mean by that? So what I think we talked about this. What is 9 to the 1/2 power? What is 9 to the 1/2 power? What does that even mean? I kind of talked about this a couple times. But if you don't remember, that's okay. But if you do remember, what does 9 to the 1/2 mean? It means square root, right? It means the square root of 9, which is 3. So 25 to the 1/2 would be square root of 25, which is 5. My question is, why? So this thinking, what would 64 to the 1/3 be? So 1/2 power means square root. What does the 1/3 power mean? Ooh, it got very quiet. Well, it's been very quiet, but the chat room is very quiet. 4. And why is it 4? Why would the answer be 4? What is the 1/3 power doing? If the 1/2 power is a square root, then the 1/3 power is a cube root. Very good. So this would be the cube root of 64, which is 4. So you've just defined what fractional exponents are doing. Right? If I have something to the 1 over something power, right, that fractional exponent, that's going to be the nth root of a. So a to the 1 over n, a to the 1 over n just means a, and then that n, this number that's down here, that's your index. That's your index. So some examples. A to the 1/2 is the square root of a. A to the 1/3 is the cube root of a. A to the 1/4 is the 4th root of a, and so on, and so on, and so on. Oh, someone says, can you do one more? Yeah. A to the 1/5 would be the 5th root of A. And so on. Yeah, pretty easy. Pretty simple, right? Pretty simple. Okay. What if, I'm trying to get a blank space here. What if I told you, 9, let me see. What is 9? I'm trying to think of one that, 9 to the 2/3 mean. What if that number on the top, what if this is not a 1 anymore? Because, yeah, what I just showed you was, if this was a 1, whatever's down here, that's the root, that's the index, right? So that's pretty simple. 1/2, 1/3, 1/4, 1/5. But what if that number up there is not a 1? Like, what if I had 9 to the 2/3? What would that be? Or how would that look? Okay, good. Someone said, Mister, that 3 would still be the index, right? Yes, this number down here would still be the index. So what do I put inside? So someone was right. Someone said, hey, Mister, that 3, wouldn't that still be the index, just like over here? You know how that 2 was the index, and that 3 was the index, and that 4 was the index, and that 5 was the index? Yeah. So whenever you see a fractional exponent, that number on the bottom is the root you're taking, is the index. But what about this number on the top? Wow, very good. Yes, it just goes inside with the 9. So this would be 9 squared. Right? So when we see a fractional exponent, this top number is the exponent of that number that goes inside. And then the bottom number is just the index. So this basically just means 9 squared, the cube root of 9 squared. Top number goes inside with this number. Bottom number is your index, is the root you're taking. And so then I would simplify that. It would be the cube root of 81. And what's the cube root of 81? Well, we can simplify that and so on. That 81 isn't a perfect cube, right? But we can find a perfect cube in there. Right? We could say 81 is the same thing as 27 times 3. Cube root of 27 times 3. Then we can say cube root of 27 times the cube root of 3. Well, the cube root of 27 is 3. So this is 3 cube root of 3. Okay. But the whole thing, okay, yes, we practiced doing this before, simplifying radicals. But the whole key for this lesson is, can you change this to look like this? Or can you change this to look like that? You need to be able to go both ways. You need to be able to convert the fractional exponents to radicals and the radicals back to fractional exponents. So let's make our little rule here. So what if I have a number raised to a fraction where I have a number in the numerator, number in the denominator? Same thing, right? A is still in here. That n is still your index, but this m stays with the n, stays with the a. Okay. There's also a second way to do this. So I'm going to put an or. Let me put or. We still have the nth root. We still put the a in here. Or I can put the m last like that. Okay. So this m, this number at the top, usually it'll just go inside the radical with the a, with whatever number this is. But sometimes it might make it easier to just put the nth root here, and then the a inside, and then this m we can do last. It can be last. It can be put over everything. Usually this is what we do. This is the most common way, but this is possible too. You'll get the same answer. Again, this is the most common way to do it. This m just attaches with that a inside. And this denominator is always the index. This denominator is always the index. Okay? So that's all we're doing. Can you rewrite this in radical form? So that's the first things we're doing. And then, can you get the radicals and change them to exponential form? Okay? So like this, what would that be? So these first problems we want to know how to do. We want to know how to convert between exponential and radical form. So these first ones, we have the exponential form. I want to write them as radicals. So that's what we're going to do in these first 9 examples. We're not going to do all 9. We'll do a couple till you understand it. And then the second ones, I give you the radicals. Can you write them in exponential form? So let's do a couple. This is an easy one. What would this be? Anyone? What would that be? X to the 1/4. Well, you know it's going to be a radical, right? You know I'm going to change it to a radical. And what goes inside? What goes inside the radical? Hello, people. Are you there? Anyone there? Hello. Hello. Thank you. Thank you. The X goes in there. The X goes in there. This space goes in there. The index, right? This number in the fraction, that goes right here. So this is the 4th root of X. Right? The base is what goes inside. Some people said the 4 goes inside. I had 3 people message me that. No, this goes inside. And then the fractional exponent tells you this number in the bottom is your root. This number in the top is the power that goes right there. But what's x to the first is just x. Yeah? Okay, looks like some of you are confused. You were putting the 4 in there. Okay, try this one. What would this look like? So what is being put to the half power? So yes, we have a radical. This is a 2, so it's a square root. No, I'll put the 2 here, but you don't have to for a square root. What do you mean you don't understand why there's no index? Yeah, the index is 2. But when square root, we usually, if you don't write an index in there, you know it's a 2. But we can put the 2 there if we want to. And then, since this is in parentheses, all of this is being raised to this power. So that means all of this goes inside 15n. Yeah, if there's no index, that just means there's a 2 there, right? When you don't see an index, that means square root, right? You guys understand that, right? When you don't see a number here, you know it's a 2 because no number here means square root. But I mean, you could write a 2 in there if you want to. Okay, I need to see, guys, if you're not going to speak or type in the chat, I need to see thumbs up or something, or thumbs down if you're not getting this. Because this is the easy lesson. And if you're not understanding this easy lesson, tomorrow's lesson is going to be tough. We're not solving for anything. We're not doing any equations. We're just converting. If I give you a fractional exponent, can you make it a radical? If I give you a radical, can you make it a fractional exponent? Okay? Everyone good with 1 and 2? I need to see a yes in the chat or a thumbs up or some type of communication with me. Thank you. Thank you. If you're not understanding, I need to see a thumbs down. You can give me a C. You can do that too. Thank you. Oh, there you go. I just need some feedback. Otherwise, it's just a desolate desert of silence. Like I was saying the other day when I was talking to you guys about college and all that stuff, I'm like, sometimes I feel like I'm talking on deaf ears, like I'm just talking to myself and no one's listening to me. I tell you, just a desolate desert. But a few of you wrote to me saying, "No, Mister, I'm listening to you. It's just sometimes we, in this whole pandemic, online learning, we just We're just used to just listening and being here and not participating, which is kind of sad. All right, so if you get it, then what would this be? And simplify it if you can, right? So that's what they say right here, simplify if needed. So what would 24 to the 1/3 be? And whatever that would be, can you simplify it? So I'll give you a minute to think about that one. Because here's a clue, there is some simplification going on. All right, time is up. So I think most of you that send me answers, you got a radical. 3 is your index. 24 is your radicand. It's your insides. And so some of you stop there. But no, let's think about it. We're taking the cube root of 24. So that means we need to take the cube root. Are there any perfect cubes inside 24? Well, 24 is not a perfect cube. But are there any inside 24? And some of you said, oh, 24 is 6 times 4. Yes, you're right. 24 is 6 times 4. But is 6 a perfect cube? Right? Can I get 6 by multiplying a number to itself 3 times? No. Is 4 a perfect cube? No. Then somebody said in there, ooh, mister, 12 times 2. Perfect. 12 times 2 is great. But 12, not a perfect cube. 2, not a perfect cube. Ooh, someone just said it right now. Mister, what about 8 times 3? Yes, because 8 is a perfect cube. 8 is 2 times 2 times 2. So I would do this, cube root of 8 times 3. Then I would separate them, cube root of 8 times the cube root of 3. Well, the cube root of 8 is 2. And this that would stay the same, cube root of 3. Yeah? All right, let's try a tough one. Which one do you want to try? From 4 through 9. Let's try one more from 4 through 9. Someone said, wait. Sorry. You're right. I did rush through that. Thank you. I had 4 people. Wait, what are you doing? Hold your horses. Stop. Going too fast. Thank you. You need to tell me that. You need to communicate with me. Isn't there a slow down reaction in there? Yeah, there you go. Someone's telling me to slow down. Mr. Davila is telling me to slow down. There it is. Okay, so you understand what we do? The big part of this, the main part of this lesson is how did you go from here to here? The rest of this is review from what we did before, simplifying radicals. Right? But our lesson is this. This is our focus. This is our objective. Can you do this? Okay. If you can do that, great. You know this lesson. If you are having trouble with this, that means you're having trouble with our previous lesson. You need to go back and review, right? Because this is a review of what we've done before. I'll give you 10 more seconds and then we'll move on. And you get to tell me which one you want me to do, which one looks difficult, and we'll do it together. And then you'll say, oh, that's it. And I'll say yes. Three, 2, 1. Okay, which one of these do you want me to do? Because then we're going to do radicals to exponents. 8 and 9. Okay, I'll do 8 and 9. So if we look here at 8, so I'll do 8. And then I'll have you do 9, and then we'll go over it. So we have a radical. Of course, we're going to have a radical. What goes here in the index of this radical? The 3. Very good. What goes inside? Well, whatever is in parentheses is to this power. So whatever's in parentheses goes inside. So I have negative 6x. And what power is that raised to? It's raised to the second power. The second power. Okay. So that's how we go from exponential to radical. This whole thing, these parentheses mean this whole thing is raised to this power. So that means this whole thing goes inside. This 3 is our index. And this 2 is the power of this whole thing. So I got to keep it in parentheses and put the 2 there. Now let's clean it up. So now we have the cube root of negative 6x squared. Well, let's square. What's negative 6 squared? 36. And what's x to the second power? X squared. And so we have a cube root. Let's think about it. Cube root of 36. Well, let's break down 36 like we did before. 36 is 6 times 6. 6 is 3 times 2. 6 is 3 times 2. Do I have 3 of anything right here? No, I don't. So this cannot be simplified, so I'm done. There are no cubes in there. 36 is 6 times 6. 6 is 3 times 2. 6 is 3 times 2. I only have 2 3s and 2 2s. I don't have 3 of anything. I don't have anything to the third power. So nothing would cancel out, so everything stays in there. And that's it. That makes sense? So these parentheses matter. Pay attention to these parentheses. That is what is being put to that power. If it's not in parentheses, it's totally separate. And you'll see that in number 9. So go ahead and copy this. Okay, let's look at number 9 now. So again, what is in parentheses is being raised to that power. So if we look here, you see this 7? This 7 has nothing to do with that 1/2. Nothing. What's being raised to the 1/2 power is the 12w. So this 7 just stays a 7. This part right here is what changes to a radical. Is that clear? Oh, okay. Someone wants me to go back really quick. Sure. Five, 4, 3. Were there any questions on this before I finish, before I go on to number 9? No? Okay. So again, this 7 is not in the parentheses, so it has nothing to do with this 1/2. Okay. This is in parentheses, so this is my base raised to this power. So that means this part is my radical. So the 7 just stays outside. And so my radical is 2 is my index, 12w stays inside, and it's to the first power. So I could put it to the first power, but I don't have to do to the first power, just stays the same. So that's why we don't put that. And we're done. No, we're not, mister. Oh, we're not. You're right. Can we simplify that? This is the square root of 12. So I still have my 7 out here. Now, what's the square root of 12? Let's do this on the side. Let's do this on the side. What's the square root of 12? Well, the square root of 12, there is no square root of 12. But square root of 4 times 3. Square root of 4 times square root of 3 becomes 2 square root of 3. So this part becomes 2 square root of 3. And then the w stays inside because I couldn't do anything with that. And then I still have a 7 out here, so these two multiply, so it becomes 14 square root of 3w. Okay? Again, for this lesson, you need to know how to do this. That's this lesson. Can I change from a fractional exponent to a radical? If you can do that, you got this lesson. Now, to get from here to here is our previous lesson. And if you don't remember how to do that, where I did all this and simplified, you need to go review those notes. Any questions on that? right? This 7, again, this 7 had nothing to do with it, so it was not inside the radical. The 7 was just outside the whole time. And then this became a radical. And then I simplified the square root of 12. I did that over here. Square root of 12 is the same thing as 2 square root of 3. And so that's why this became 2 square root of 3. And then that w, there was nothing I could do with that w, so that w just stays inside with the 3. And so since I had a 7 and a 2 on the outside, I multiply those. That's why I got 14. And then the 3w just stayed on the inside. Yeah, I see 2 people saying yes. The rest of you, I hear nothing from you. I don't see a yes. I don't see a thumbs up. I don't see a... Oh, there we go. There we go. Thank you. All right. Can you go backwards, right? A lot of you are learning how to drive right now, or maybe you've the last couple of years you learned how to drive and you're driving right now. And one of the hardest things that, or not hardest, but something you had to get used to was, okay, you started getting good at driving forward, but then when you started driving backwards, it was a little trickier. So that's what we're going to do right here. I'm going to give you the radicals, and you're going to give me the exponentials. Okay? So I want you to try number 10. And it says right here, write an expression in exponential form. Now I'm going to show you a couple things of how it can be rewritten, but there is no simplifying really. Well, kind of, but I'll show you what I mean. So go ahead and try. What's the cube root of 16? That should take you about 5 seconds to do. Cube root of 16 is, well, we just do the opposite of what we've been doing in there. So you look at your insides. So your inside 16, and that's your base. And then you're going to have it to a fractional exponent. Well, it's 16 to the first power, right? So I just put a 1 up there. And then my index is 3. So I'm done. Now, could this be written differently if you want to get a little fancy? Yes, it could. Yes, it could. You could say, oh, 16 is 4 squared, isn't it? So I can also write 4 to the 2/3. Same thing, right? 4, because that's the base in here. That's my base. And then 2 is my exponent, so that goes up here. And 3 is my index, that goes down here. That's exactly the same thing. If you wanted to get even fancier, you could have said, oh, 16, isn't that 2 to the 4th power? Cube root. And then so I can do 2 to the 4/3. Is that also an answer, mister? Yes, if you want to get fancy, yes. So we'll call these Mr. Fancy Pants. But this is all you need to do. I just want to, can you get what's pictured right here and change it to an exponential? Are these correct down here? Yes, they are. But then, Mr. Fancy Pants, right? You're getting a little, okay. You're getting a little extra right there. And it's okay. It's still correct. And if you see all 3 of these terms, they're all correct. If someone asks you, how old are you? You can say, well, I guess not, because that won't work because it's a cube root. Never mind. But yeah, Mr. Fancy Pants. Yeah, I guess if someone asks you, how old are you? You can say you're 16, or you can say you're 4 squared, or you can say you're 2 to the 4th. Right? How do you normally say it in real life? Right? We just say 16 is 16, so the cube root of 16 is just the cube root of 1/3. But some of you get fancy, and you use that for 16, and then it can change to that. But this is all you need to do. All right? So here's what we're going to do. Tomorrow we will review this a little bit. We'll do some of these more tougher ones over here. Right? Some of you that want to look ahead and look at the notes, the note solutions, you can try a few of these on your own and look and see if you're doing it correctly. And then we're going to look at these expressions and how we simplify them and then write them as radicals. Look at these expressions. So you have to remember your exponent rules. Okay? And then that's it. No, homework is not due today. As I said before, all the homework this week I'm going to put due for Monday. Okay? Because Monday you don't have me for this class, right? You just have your advisory. So I'm going to put all tonight's homework, this homework and the homework for radical equations, which we're going to start tomorrow. It'll be due on Monday. So yeah, you're not ready to finish this homework anyway, because we haven't talked about these kind of problems. Oh my gosh. About these kind of problems. So we'll do that tomorrow. So if you have any questions, let me know. If you need any help with anything, let me know. Have a great Wednesday. And I will see you all tomorrow. Take care. Bye, Mr. Davila. You too.